Okay, so again, when we say a process, it is a program in execution. And when we run a certain program, let's say you open a Firefox or a Google Chrome on a modern system, we are presented with the illusion that our program is the only one currently running in the system. So for example, at this point, I am opening or I am running the Zoom. So parang it gives you for a user, it gives you the illusion that only the Zoom application is running in your computer. Okay, so it appears that our program appears to have the exclusive use of both the processor as well as the memory. Okay, so remember that when we are running a certain application, it uses a certain or it is allocated with a certain part of the memory as well as the CPU or the processor. So it appears that, let's say the processor execute the instructions in our program without interruptions. For example, we are continually using Zoom. Sorry. So it appears to the user that there are no other applications that are running in the background. Okay, and also finally, our code and data of our program appear to be the only objects in the system's memory. So these are the illusions that are provided to us by the notion or the idea of a process. Okay, so the context consists of the state of the program. So when we are running a certain program, the program includes the code as well as the data that are stored in the memory, its stack, or the contents of its general purpose registers, its program counters, as well as the environment variables. So wait a minute. So as you can see here, when you open your Windows na disk manager, or in my case, it's the activity monitor. Sorry, hindi ako makapagsalita. So sorry for the interruption. So again, every time when we use a program, so for example, I am using a Firefox as well as Adobe, let's say, it appears on the activity monitor. So it's the same in Windows. So ano nga ulit, how do you find the running applications in your program? How do you find the running applications in your program? Equivalent to this part. So for example, bigla nag-lag yung computer nyo. So you terminate a certain application through this. What do you call
Task
that?
manager.
Yeah, it is the task manager. Thank you. Thank you for your answers. Okay. So in the task manager or in the activity monitoring the application, you can see all the processes that are running. Okay. So when you open a certain application, so for example, you open Firefox, it creates new processes and also executes those processes. So an operating system executes a variety of programs. So for example, it could be the user programs, or it could be the programs or codes that must be run by the operating system, or a combination of both, etc. So potentially or ideally, all of these processes must or can execute concurrently. So when we say concurrently, they could overlap. They can execute in parallel. Okay. Do you understand what a process is? Anyone? Gets nyo ba?
Yes po.
Okay. Are you sure? Okay. So again, when we are running a process, we have mentioned earlier that this includes the program code as well as the data stored in its memory, stack, and contents of its general purpose register. So you can also see in your task manager, let's say when you open a certain application, you can see how much percent of the CPU or the processor it is allocated with, and then how much time it has used the CPU, also other information available. And there's also the process ID. So each of the processes that are running in your computers have the process ID. Okay. So, anyone, what is the difference between a process and a program? Any idea? Any guesses? Guesses lang. What's the difference between a process and a program?
Hello po.
Yes, who's speaking?
Si Lloyd po yata. Lloyd.
Lloyd, okay. Yes, Lloyd?
So from the definition of process po kanina, ma'am, yung difference po siguro nila is yung program is parang static lang po siya na set of codes, and once you run that po, yung nagiging process na po siya.
That is correct. So because we have mentioned earlier that a process is a program in execution, correct? So thank you, Lloyd, for that answer. So when we say a process, it is an instance also of a running program. And it is essentially one of the most profound ideas in computer science. So we mentioned that when you say a program, it is also constituted of different processes. So when you run a certain program, when you run or execute, let's say when you open a Google Chrome, it is constituted of different processes itself. Okay, so for example, we have a program here, and let's say you have the C code, and then you have some functions. Okay, so this is, as Lloyd said earlier, the static program. Once you execute the program, it becomes a series or instances of processes. So for example, nag-call ka ng main. So it gets added to the heap or the stack, and then the main calls A, for example, then it will get added to your stack. And all of the registers, as well as the variables that you have used, will be added to this, added to memory, etc. So when you run, or again, when you execute a certain program, it becomes a series or instances of different processes. Okay, so a program can invoke more than one process. And also a very simple example. So when we say that you open a Google Chrome or Firefox or or Safari, so those are examples of a web browser. So when you open a certain web browser, it launches also to multiple processes, like one per tab. So for example, we are using a Zoom application right now. So the Zoom has different processes, let's say for accepting or interpret, not really interpret, but to receive the audio inputs. Also, the Zoom has a process that allows us to view the participants. So for example, if I set or click, or I choose one of you to become my co-host, that becomes a process. There is also a process that runs concurrently along with these processes while with the recording, diba? So these are example of processes. Okay, so you can see here, for instance, I was using a Firefox, and the Firefox is an application program that we can use, and when we run this application program, then there are several na processes that are associated with it. So another example here is, for instance, I have a running na C na program, and then when I to run it or debug it, you can see that the step-by-step na operation on how it is being compiled, as well as how it is being linked or loaded into the memory, are being shown here. Okay? So, gets ba? Medyo clear naman? Okay. So, are you all good pa? Anyone? Wait, can you hear me, or kahit thumbs up lang? Okay, thank you, Anne, for the interaction. Okay. So, anyway, let's just move on from here. This is just an example of when I tried to open a socket process, and you can see the all of the details on when and how a series of processes and their addresses in the memory, etc. Okay, and also when they terminate and when new processes are being started. Okay, so you can play on your Windows Manager, and you can also Windows Task Manager, and also observe the processes that are running in your computers. Okay, so when we say a process provides each program with the illusion that it has exclusive use of the processor, even though many programs are typically running concurrently on the system. So the process provides this layer of two layers of abstraction. Okay? So abstraction, bakit sinabing abstraction? Again, because the process provides each program with the illusion that only one process has exclusive use of the processor or the memory. So it has the logical control flow, and and this illusion is enabled by the kernel mechanism called the context switching. So we are going to discuss more later about the context switching. We have a separate slides for this. So basically, this context switching allows us to run concurrent na processes or running processes in parallel. Okay, and also another na abstraction is that the private na address space. So it appears to the user that each program seems to have an exclusive use of the memory, but in reality, there are different programs that are being stored or allocated in the memory. Okay, so this is also provided by the kernel, the mechanism called the virtual memory. Okay, so let's discuss this one by one. So let's start with the logical control flow. So you can see here, as I said, it is an illusion that only one process is being stored or is being executed by your CPU. Okay, so the OS simplifies and gives us that kind of illusion. But in fact, there are different na processes that are actually running. Okay, so it could be another Google Chrome na tab, or another na Slack, or another na process which uses a PowerPoint. Okay, and all of these processes have a space in the disk, or all of these applications pala have allocated na space in the disk. All right, so what happens is, you can see here the animation. Right, so the processes take turns using the processor. So each process executes a certain portion of its flow and preempted, or in other words, temporarily suspended. So as you can see here, initially, yung unang nakaload is the first na tab, let's say, of your Google Chrome. And then another na process took turn in using the CPU. Okay, so this process 1 was temporarily suspended or preempted, so this other process could run or use the CPU. Okay, so to a program running in the context in one of these processes, so it appears to have the exclusive use of the processor. So the only evidence to the contrary is if we are to precisely measure the elapsed time of instruction, we would notice that the CPU actually appears to periodically stall between different executions of each instruction in our program. So, however, each time the processor stalls, it subsequently resumes execution of our programs without any change in the contents of the program's memory locations or register. So, yung ibig sabihin nun is even if we have, let's say, different processes that are taking turns on using the CPU, what happens is this process keeps this data to itself or this data in memory to itself. So, hindi to siya nagbabago. Okay? So, kahit na, for example, nauna na nag-run yung process 1 and then nag-exchange sila ni process 2, still, this information or kung anong virtual memory yung inallocate kay process 1 or process 2, it will remain until the end of its execution. Okay? So, wait lang ha. So, hello again, everyone. Sorry for the interruption. I just received the meds delivered by Tok Tok. Anyway, sorry. So again, my question ako, na-notice nyo ba na minsan if there are so many processes in your computers, running in your computers, may tendency na mag-lag siya? Right? So does it have you experienced that kind of scenario? Yeah. So
Yes po.
pag naglalag yung computer nyo, does not necessarily mean na nag-terminate na yung process mo, right? So you just have to like patiently wait and not do more clicks or i-bombard nyo yung keyboard nyo with several na refresh and what. Kasi that will just add more processes to be done by your CPU. Okay? So, yeah, true. Refresh the empower nga. So, anyway, as review, so we have several processes that take turns into using the CPU when in fact the memory is the space in the memory that it's allocated with does not change. So now moving on, so we have discussed the logical control flow, wherein each program seems to have an exclusive use of the CPU, but in fact, there is a context na switching that is happening in the background or different na processes that are taking turns in using the CPU. Okay, so another abstraction that the process provides is the private address space. So each program seems to have an exclusive use of the memory, or that is provided by the kernel mechanism called the virtual memory. So we'll discuss that more later. So here's the illusion. The illusion is that the illusion is that the computer runs many processes simultaneously. So there might be applications for one or more users, as well as the background tasks for monitoring network and I/O devices. So it appears to the user that each of the processes have its own memory. So when in fact, the reality is that these processes are sharing a virtual space in the memory, or sharing the memory. So a single processor executes executes multiple processes concurrently, and the process executions are interleaved, or CPU runs one at a time. So it appears na parang they all run at the same time. But in fact, what happens is the executions are interleaved. Process A will execute, then will temporarily suspend. Process B will execute, then B will stop executing, then it will go back to process A, continue or resume its application, then temporarily stop again, then B will run again, and then another process, etc. Okay, so that's what it means by the interleaved, the process execution, and wherein the CPU runs one at a time. So the address spaces, on the other hand, or the space in the memory where the certain processes are allocated or as managed, are by the virtual memory system, which we will discuss later in the course. So each of the processes will have execution context, which stores the register, saved the register values, the stack, heap, data, program code, etc. Okay, so what happens is, you can see here, first, let's say this first process uses the CPU. Okay, and this process also has its associated na data, or what we call as the what we call as the process control block as well. So you can also call this as a process control na block. Okay, and then when this CPU, while this specific na process is using the CPU, it saves the current na registers in the memory. And next is, it will schedule the next process for execution. So it is the OS that will decide which of these processes, or which of these next processes, will be executed next. And once na, for example, once na done na scheduling, for example, the OS chooses to execute this process next, then it will load the saved registers, okay, that are, or the information in the memory that are associated with this current na process, and there is a switching that happens in the address space. Okay, so, and then there are also multi-core CPUs on a single chip, wherein they share main memory and some of the cache, and each can execute a separate na process. However, again, there is a scheduling na nangyayari, and there is also still a context na switching, or constantly swapping processes. Okay, so multiprocessing in modern reality. So you can see here several, again, going back to the previous example, several processes associated to a certain program application that are running in parallel. Okay, and are also sharing or allocated with a certain memory. Okay, so When we say concurrent na process, what does it mean? Do you remember what we have discussed earlier regarding the concurrent na processes? Any idea what a concurrent process is? Andyan pa ba kayo? Okay, so or let me know if I am going too fast so I could adjust my pacing, or if you don't understand anything, feel free so I can address it later on. Okay. Wala talaga. Are you all okay? Any response from the group?
Concurrent processes, ma'am, are processes that occur side by side.
Who's talking, by the way?
Rene, ma'am.
Rene. Thank you, Rene. So that's actually correct. So assuming we have only one CPU, so each process is we mentioned earlier, a logical na control flow. And two processes can run concurrently, or two processes are concurrent if their instruction executions flows overlap in time, or as Rene said, they are running side by side. Okay, so for example, here you can see a graph. Can you see the graph here of different processes A, B, and C? So note that A, B, and C are independent processes. Okay, and they will continue running until such time that they complete their execution. Okay, so we can say here that concurrent na processes are A and B, and A and C also, while sequential naman yung B and C. So why is this the case? So for example, the process A starts here, and then at some point it gets preempted and it gets suspended. Okay, and then the process B takes its turn and it runs for a certain period of time. Now the B stopped and already completed its execution, and while A is still running, another process has already started. It is the process na C. So at this point, start C is currently preempted or currently suspended, and we go back to process A. Process A resumes its execution and now finally gets completed. Okay, and after A already completed its execution, the process C continued its process. Okay, so we can see here that while A is running, B and C are also running. So you can see the overlapping in between the process A and the process B, and the process A as well as the process C. So we can then say that A and B are concurrent na processes, and A and C are also concurrent na processes. But we can say that the B and C are sequential na processes. Bakit siya sequential? Because after the B completed its execution, then it has been followed by the process na C. Okay, so okay, so gets nyo ba? Did I explain this? Were you able to understand this graph? Or
Yes,
what concurrent na processes or sequential processes are? Okay, so now let's have a continuation. So also, the user can think of concurrent processes as executing at the same time or in parallel. So in our minds, we think that the process A continues to run now without preemption or without suspension, right? So while it is running in parallel with B and the C. Okay, so when in fact in our CPU, there is an interleaving as well as context switching na nangyayari in order for us to run these processes in parallel. Okay, so before that, can we have a practice na problem? So you can type in the chat box your answers. So consider that we have 3 na processes with the following starting and ending times. So we have a process A, B, and C. And the start time and end time of A is from time period 1 to 3. And then, or we can also call it as time slice. And then process B started from 2 to 5. And C, started running from time period 4 to 6. So for each pair of the processes, indicate whether they run concurrently or not. So is A and B concurrent? You can, I'll give you some time. You can graph it in your, you can create a graph. And so you can see which of the processes are overlapping. Okay. I'll wait some of you to answer. Sorry. Okay, so most of you have similar answers. So may I call on who wants to answer or to volunteer answering this? Anyone? So yung mga nasa chat box na tama naman yung sagot, I think you could share to your classmate your answers. Anyone? Should I pick some people? Okay. Stop. Renmar. So what is your answer?
Hello, ma'am.
Yes.
So, process pair AB is concurrent. Process pair AC is not concurrent, and process pair BC is concurrent.
So did you get the same answer as Renmar? So suppose this is the time period. So we have 1, 2, 3. It is process A, right? And then for 2 to 4, it's process B is running. And from 4 to 6, C is running. So Renmar's answer is correct. Bakit siya correct? Because you can see here the overlapping between A and B, and there is also an overlapping between B and C. So we can say that A and B and B and C are concurrent. So what about A and C? So what kind of process are they? What kind of process A and C?
Sequential.
Sequential.
Yeah. Wow, very good, Kamo. Thank you for your answers. Okay, so going back again, what enables concurrency? Do you remember what we have discussed earlier? What enables concurrency? What enables concurrency again? So hint, it starts 2 words. Do you remember? What happens when processes are taking turns into the CPU?
Scheduling and context switching, ma'am.
Yeah. Who said that?
Chansey, ma'am.
Chansey. Okay. Thank you, Chansey. That is correct. Okay. So we have the context na switching. Okay. So Again, context switching is allows multiple processes or to share a single CPU. Right? So when a CPU switches from executing one process to another, then it must save the state of the currently or the state of the old process and then load the saved na PCB state of the next na process. Okay, I'll just show you how it happens. So, ito yung nangyayari. So, ito yung first na process occurs for some time, right? So, after for some time, nag-execute yung process P sub 0. Okay, and then it was temporarily suspended or preempted. So since it was interrupted by a system call, then all of its state, like the register, the process number, state, I will show you whether it is running, whether it is waiting for some information or detail or for some data, and then the program counter or kumbaga, ito yung sa scheduling, pang ilan siya kumbaga sa schedule, and then as well as or yung mga space sa memory that it is using, the memory limits, list of open files, etc. So all of this information or this process na control block will be saved. So now, after that, then it must load the saved state of saved state of the new na process. So ito, after mag-execute, after i-preempt muna si P sub 0, we will save its state. And then we will reload itong process control block ni PCB1. So we need information about PCB1, right? So after reloading it, mag-execute ulit si P1. So now, at this point, at this time period, temporarily, masususpend na naman siya. It will be preempted. So the PCB1, we are going to save the state of PCB1 and reload the state of PCB0. So, kumbaga kung ano yung na-save dito, then i-reload natin siya. Okay? And then it will, P sub 0 will begin executing again. So, okay? Again, so P sub 0 begins executing. Then yung state niya i-save natin. Now, since need na mag-run ni P sub 1, so i-reload natin yung state niya, then it will execute, then it temporarily gets suspended, so we are going to save its state, and since na for some time idle siya, and i-reload na naman natin si yung information about P sub 0 in order for it to run. And until such point na magko-continue lang to siya in not only between two processes, but a lot of processes until all of the processes complete its execution. Okay? So the processes are managed by a shared na chunk of OS na code called the kernel. So paano ba nangyayari yung OS na switching? How does it switch from one process to another? Okay, so the processes are managed by a shared chunk of OS na code called the kernel. So the kernel is not a separate na process, but rather runs as part of a user na process. So the context switch passes control flow from one process to another and is performed by a kernel code. So for example dito, we have two processes, A and B, and they are going to run in parallel until such time that both of them complete their execution. So at a time, the process A runs, so that is using the user code, and then there is a context switch na mangyayari using the kernel code through the exception, and the process B will begin its execution. And now, for some time, the process B runs and magre-resume si process A. So at this point na idle siya, going back here, at this point na idle siya, so dun pumapasok si kernel code or the context switching na nangyayari. Okay? And now, the A will run again. So the kernel code or the kernel na mode is also known as the privileged na mode or supervisor mode. And it is a mode in the CPU in which the CPU has full na access to all system resources, including hardware devices, memory, and the operating system itself. And the kernel mode is used by the operating system's core functions, like this, like in the process management. Okay, so at this point, yung sa kernel na code, in here the CPU can execute any instruction and can access any of the memory location. However, pag nandito naman tayo sa user code, wherein a certain process is running, this is a restricted na mode in which the CPU can only access a limited na set of resources, such as user-level programs, as well as their associated data. So the user mode is the mode that is used by applications and processes running on top of the operating system. So kung pag user mode ka, CPU cannot access certain memory locations that are reserved for the OS. Okay? So again, another term for kernel code is the supervisor na mode, and wherein the CPU has full access. But dito sa user mode, it is the time wherein the user na code or application programs are running, but restricted siya, and CPU cannot execute privileged instructions or access certain memory locations that are reserved for the OS. Okay, so now were you able to get what I said? Any reactions from you? Okay, so I got some. Oh, si Rene lang yung naka-understand. Kag si Lloyd. Okay, damo man gali. Okay, thank you for making this somehow interactive. Okay, so now for creating new processes. So, okay. Hindi to yung part ang ubos ng lecture. Kasi pumunta ko sa bat. Joke lang. Okay, so anyway, we are done with discussing the process and context na switching. So let us proceed with creating new processes. So for right now, we will just discuss the fork. Okay, so the process can be created in two ways. So it may be done through system initialization, or one or more processes that are created when the OS begins. So for example, nag-open kayo ng laptop nyo. So you can see that the laptop is booting, tapos some of the processes are being loaded into the system. So that's when, that's the system initialization. Or it may be the execution of a process creation call, system call. So for example, nag-double click kayo sa Google Chrome. So that's an example of a system call. Kumbaga na, it gives a signal to your CPU na, hey, gusto kong gumamit ng CPU. So can you give me some of your resources? So, and then nag-open ka ng bagong tab. So yeah, that's another system call. So it's something that is explicitly asks for a new na process. So the system calls can come from a user request to create a new process, or those that are already running processes. Okay, so there are different states to a process, but I'll just go over this part. So we have the, by the way, do you have class at 9 a.m.? May mga klase ba kayo 9 a.m.? Any answers? No. Wala? Wala? No, okay. Okay, for that, continue. Para baka sa Monday, we'll see if we could have a class for Monday. Oo nga, kasi wala ako sa Monday. So, continue na lang tayo ha. Tapusin na lang natin siya since wala ako sa Monday. Okay. So, when we create or create a certain process, so there will be, okay, 10 a.m. yung class. Sige, let's try to complete it by 9:15 or 9:30. Okay, so you can go right after. So once you create a process, the process will now have its state. So once it's created, masisave na yun siya sa process control block kanina na pinakita ko. Okay, so going back dito. Yan, dito. Diba, mayroon siyang process state, yung process 1. So, so pag na-create na siya, so a certain memory will be allocated for it as well as its schedule in the CPU and when it's going to run. And then pag ready na siya, then first, once it's created, the process will enter the ready queue. And after that, the scheduler will be picking this process. Okay? Kailangan niya kasing i-schedule kung when siya i-run. So once na nag-run na siya, then it could go this way. Pwedeng it will go back to a ready state because the scheduler picks a different process. So ito yung time wherein may interleaving na nangyayari or context switching. So for example, process A, nag-create na siya, ready na siya, na-schedule na siya, and it's already running. And let's say mag-run naman siya ng another process or scheduler picks another process. So it will enter again the ready queue. Okay? And it will continue until such time that it will complete its execution. So in another case wherein a process gets created, it gets, and then the scheduler picks this process, and then another option is it is blocked or it waits for an event. So for example, it needs additional na input-output, or maybe it's waiting for an information that is given by another process, or it may be waiting for the result of another process. So nasa blocked and waiting pa siya. So after niya nun, na makuha yung kailangan niya, then it enters into the ready state again and i-reschedule ulit siya until such time na matapos and mag-done na yung execution. Okay? So, when we are creating new processes, we can, in C in a program, we can use a fork. So for example, we have a process 1, and then we are performing a fork. So basically, it will just duplicate this process. Okay? So, yung exec naman is that totally na i-replace niya yung old na process. Okay, so today we will focus on the fork. As you can see here, pag nag-fork ka, this another child na process, ito magiging child to siya ng parent na process 1, and it will simply duplicate this process 1. Okay? So, when we are creating new processes, the parent process creates children processes, which in turn create other processes, forming a tree of processes. So generally, a process identified and managed via a process identifier or PID. So it seems a little confusing pa, just reading all of these definitions, but stay strong, and we'll have better applications in the next slides. Okay, so again, we are using fork when creating new processes. So for example, we have PIDT, so we are creating an object, and then fork, then this will create a new child process that is identical to the calling parent process, including all state, memory, registers, etc. And it returns a 0 to the child process, and it returns child process ID to the parent process. Okay, so parang ang hirap pa siya intindihin, but again, stay strong. Babalikan natin to siya. Okay, so going back here, sinabi natin dito na when it creates a child process, so this, when we create a child process, identical yung child na to sa parent niya. Okay, gets back? So, including all state, memory, registers, etc. So we will understand this later. Let me just show you an example. So when we do a fork, so basically, when we perform fork, the parent na processes will be waiting. Okay? Will be waiting because once na nag-fork ka, a child will be created. And when the child is created, it will complete its execution until such time na matatapos siya. So once na matapos na mag-execute yung child process, that's the time wherein the parent will start to resume with its execution. Okay, so let's have an example. So ito siya. So we have a main na function. Okay, and then you can see here that we performed a fork. So when we perform the fork, we are basically making a system call or magsisignal na, I am going to be creating a child na process. Okay? Or I want to duplicate this process. And then after doing the fork, then it will print by. Okay? So mangyayari is that first, we have the P1. So this will be our root na process. And then it will execute the fork. So once na mag-execute yung fork, it will basically duplicate this process. Okay? This creates a child process, duplicate a child process that is identical to its parent. Yes? So, bale, you can see na done na yung execution dito. Okay? Done na yung execution. So, yung dito siya, yung next instruction that will be executed will be the by na function. Okay? So, at this point, done na yung execution na P2. So, magre-resume na si P1. Babalik ka na dito. And it will also print a by na statement. Okay? Gets ba? Were you able to understand? Were you able to understand? Or na? Okay. Sabi ni Anne, okay daw. Thank you, Anne. Okay, so anong ibig sabihin nito? Sabi ko kanina, it will return a 0 to the child process and return the process ID to the parent process. Anong ibig sabihin nito? So, sinabi dito na pag nag-fork tayo, so i-copy niya to, di ba? Mag-create siya ng identical na process to the parent. So, this is now the P2. So, nung na-create na yung P2 na process, which is the child process, as a process ID is assigned to it. So, the assuming that this process 2 has a PID or process ID of 3,000. Okay? So, yung mangyayari is that this PID na 3,000 will be what will be returned to this fork na call. Okay? This fork na call. And 0 yung i-return sa child. So, that's how we can track which one is the parent and which one is the child. Okay? Gets? So, once nag-call, na-create yung process, mag-a-assign ng PID dito, and this PID that is assigned will be returned to the parent. So, dito, yung i-return niya is 3,000, while dito, 0 siya. Okay? Yeah. So, another example. What if we have 2 nested na forks? So, any guesses on what could possibly happen with this part? Any guesses? Guesses lang siya. So any guesses how many times this will run or print by? So in the previous na example natin, it printed by twice. Okay? And nag-fork ka once lang. How about for example 2? How many times? So, yeah, yes, a child will create another process. That is correct. We will now have a tree hierarchy. Okay? So, mag-call ka ng fork, then create ng process, and then the child will also create another process. So, how many processes will be created? What do you think? And how many times the by will be printed? Any guesses? Sorry. 3, 8, 3. Bakit says 3? Sige, let us have some more. Let us see how this will happen. So now here we have the first na fork call. Oops. So now we have the first call. Okay. So after this fork was executed, a copy of P1 was created. Okay, and then it will begin its execution here. Okay, so again, pag nung natawag yung fork na to, this, assuming na 3,000 yung ID ng process na to, it will be returned to this fork and then 0 naman dito. Okay, so 0. This is supposed to be 0. Yung dito. Return to the child. Let me just edit that. Okay, let me just, oops, nawala. So dito, I'll just edit this to 0, return to the child. Okay. Oh. Okay, so now, after nun, mag-execute na, then ito naman yung next na fork, yung mag-execute. Okay? So after mag-run yung fork na to, another process 3 will be created. So assuming that the process 3 has a PID of 3527, so PID 3527 will be returned to the parent and 0 will be returned to the child. Okay? So now, it will move on to this part and the buy will be executed. Okay? And then it will resume, P2 will resume, and then it will print the remaining statement na buy. Okay? And after nito, babalik naman siya sa parent na process. So, meron pa tayong natitira dito na 2 lines na hindi pa na-execute. So, this fork will be executed and it will create a copy of this P1. So, we now have the 2 forks that are done executing, and then this will execute, and then the buy statement will print. Then it will resume again, P1 will resume and print the buy. So, you can see na apat na processes or 4 buys are printed. Okay? Let's have another example dito. So what if may tatlong forks na? So dito i-run yung first fork and then copying this part. And then next is this second, the fork of the child process. And then basically copying P2. And this, while this P2 is running, P3 must complete its execution. Okay, so basically you can interpret it like that. And then, so that's how you know that it runs in parallel. So now, this third na fork of P3 will run, and this will print the buy. Okay, and the P3 will resume, printing buy as well. And then P2 will resume, and then it will run the fork. Again, so basically copying all this, identical na siya. And this P5 must run muna, complete executing. So this printf na buy will execute, and once P5 is done executing, it will go back to P2, or P2 will resume and complete its execution. And then, so P2 is now done executing as well as the execution of its child na processes. So now, the parent will resume its execution. So meron pang dalawang fork dito na need i-run plus another printf. So this will run the second na fork, basically copying P1. So now we have the P6. So P6 will start with its execution dito, fork and then the print by. So it will create another fork, basically copying all the P6. And then the P7 will execute, printing by. Then P6 will resume, and then printing by again, and then P6 is done with its execution. So P1 will run. So meron pang natitirang. So dito siya magre-resume. Dito siya need mag-resume. Okay? So basically, ikakopy niya to, and then all of the forks are done, completed na siya. And then P8 will execute. And then magre-return naman sa P1, magre-resume ulit yung P1 printing by. So there are basically 8 na processes. Okay, so medyo difficult lang siya i-understand, but when you delve more deeper into going back again to the different going back again to this interactive na example, then you will understand. So basically, yung mangyayari kanina is that the P1 created the P2 process, and then P2 creating P3 and P4. Okay? So now, kumbaga, itong P1, P2, P1 ito, wait lang ha. Kumbaga, we can then say na yung P1 na to and P4, P2, P1 and P2, P1 and P5, and P1 and P3 are interleaved or running in parallel. Okay? Kasi si P1, gagawa siya ng child, and then P2 will run its process, then created another child. So itong si P2 and P3, and then P2 and P4 are also concurrent din sila in nature. Kasi need mag-execute muna ni P4 before matapos si P3. Need muna mag-execute ni P3 before mag-execute ni P2. Okay? Until such time na matapos na siya. And then P2 and P5 are also concurrent in nature. And then once na matapos na to si P2, then go back to P1. Okay? So si P1, ginawa niya ulit si P5 na child, and then P7. So itong, ano yung mga concurrent? Si P1, P5, and P5, and P1 and P7, as well as P5 and P7. Okay? Gets nyo ba? Yeah, that's actually my question for you. So the question of your classmate na unahan ako is that what would be the number of processes that will be created? What will be the total number of processes that will be created? So any general? Yeah, correct. Thank you for these answers, Myrtle, Charisse, as well as Lloyd. It is 2:n na fork processes. Okay? So, bakit siya 2:n? Pag isang fork process lang siya, di ba dalawang process yung na-create. If dalawang fork process, 4 na processes yung na-create. But if tatlong fork processes, you have 8 processes na-create. So basically, you have 2:n. So thank you for your very smart na answers. So that is where we end, as well as the processes that will end. So the conditions that terminate processes may be voluntary, or it could also be involuntary. And yung voluntary, yun yung mga normal exits or the error exits. So for example, nagko-compile kayo ng code nyo, and then bigla nyo siyang hindi pa siya natapos mag-execute, nag-control Z kayo. So, or natapos na yung execution, so that's the normal exit or the error exit. So yung involuntary those are the fatal error or might be killed by another process. Okay, so for instance, nagko-compile kayo ng code nyo and biglang may error. So, hindi na siya natapos mag-compile. Terminate na yung process. Okay, so alternatively, you can also use the exit na function to end a process. So, we will have example for this later. And next meeting, we'll try to discuss more on fork, exec, wait, exit, as well as zombies. Okay, so for now, mga nested na forks pa lang yung na-discuss natin. And there are more complicated na more complex na codes like using if-else na conditions, etc. Okay? So, this is it for today. And I'll see you more, I think, Thursday, because we have student recruitment activities on March 6th, and I will not be able to meet you. Okay? So I hope you were able to understand the lessons, and I will be uploading the slides as well as the recordings mamaya. Okay? Thank you for attending the class, and I'll see you again on Friday. So, Thursday pala. Bye-bye. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Okay, ma'am. Thank you.